Hi, my name is Samantha Haynes. I'm part of the TECHSCENE 2021 REU cohort, and I worked on this project with Brooke Carter. We studied the investigation of heavy metal contamination in wild rice beds in the Quanah Bay area. Rice is the largest global staple crop, which is why it's very important. We're studying it because rice grows in an anaerobic growing condition, which creates an environment where the rice can uptake more heavy metals and pollutants than other plants usually would. Also, rice, considering it's such a staple food, so many people eat it, and they eat it quite frequently depending on their culture. So it's important that we gather reputable data regarding how much heavy metal contamination there may be in the rice in this area so we can protect the community and the people who eat rice frequently. For example, the Quanah Bay Indian community considers their wild rice, the manuman, to be very sacred to their culture because it's part of their origin story. They eat rice quite frequently, and they also grow in the area. So once we've gathered more data, we're going to release a report for the Quanah Bay area through the Natural Resource Department website at the KBIC, and it's just going to be an educational resource available to the public about the heavy metal contamination levels as well as precautions that the community can take while eating their rice or just while being in the community in general with the heavy metal contamination. So Michigan Tech was started in 1885 to be a metallurgy school because the mining industry in the area was booming because of the copper. So due to the copper mining and the other mining in the area, that has led to increased contamination of heavy metals and copper and different pollutants as well from mining. So since this is such a staple food of the Quanah Bay Indian community, we are going to take samples from different places that they've planted the rice in the area, as well as places that don't have any rice or contamination. So for our project, we took location samples at 4 locations. 3 of them were at Sandpoint Sloughs. We took them at the east side, the north side, and south side. And you can actually see it on the photo in the top right of the data column. That is the map of where we took the samples from Sandpoint. And then on the same map, we also took samples from the Fishing Derby Lake, which is one of our controls that does not have rice growing, and it is not connected to Lake Superior, so it is not contaminated by the stamp sands. So once we took the samples there, we also took samples at Lake Plumbago, which is not contaminated by stamp sands either because it is not connected to Lake Superior. It is actually connected to the Plumbago creeks and streams that come off of the mountains. And because the mountains have sediments and other metals and rocks on them, all of the water that runs down goes into where we took samples and where the rice grows. So different types of metals and sediments will end up in our sample data for that too. So once we collected all of our water and sediment samples from each of the locations, we brought them to the lab to test them for different soil characterization tests. First, we tested for pH and electrical conductivity, and we also tested for soil moisture content. We tested for this so we could use it in the Walkley-Black method for the calculations of the organic matter for all of our samples. So for the samples, all of our data came back for the pH and the EC and the soil moisture content fairly decent. All of the data was fairly similar to other soil and water samples that may be contaminated. And our organic matter percentages were actually lower than we thought they may be. Most likely considering the heavy metal contamination has depleted the organic matter in the soils that we collected. So in the graphs below the electrical conductivity, pH, organic matter, and soil moisture content graph, it shows the levels of copper and chromium as well as the exchangeable fraction copper in the soil from our acid digestion testing. So during the acid digestion testing, the levels were actually not low enough to detect some of our samples. So we will have to do those again. But in general, the RCRA heavy metal results that we did collect from our soil samples and our water samples did come back relatively similar to other soil and water samples that have been tested for heavy metal in the area and in also other similarly polluted areas. So, from all the data that we collected from the acid digestion and the soil characterization tests, there wasn't much data that we could pull any trends from or draw any real conclusions. The only thing that we plan on doing is collecting more samples in the future, taking more tests on those samples so we can collect a greater level of data and have more reputable data source for the entire project and our reports. So in the future, we're going to take those more samples. We are also going to release a survey. We were going to originally conduct it with the Quanah Bay Indian community, but rather we've decided we are going to conduct it with the Michigan Technological University and the following community to gauge their knowledge of the stamp sand contamination as well as their familiarity with the Quanah Bay Indian community. So some of the challenges and limitations that we went through with this project, one of them was working with the Quanah Bay Indian community and making sure that we were respectful the entire time. Considering that our project highlights manumin and wild rice, that is very sacred to the community. So we just had to take it upon ourselves to educate ourselves and also ensure that we weren't stepping over any lines while we were working with them. We just wanted to make a super respectful scientific partnership with them. So while we were doing that, we just stayed mindful of all of their cultural practices. Also, we suffered from time limitations, clearly. Our program is only 8 weeks long, which does not leave us much time to complete a report, a survey, a presentation, a poster, collecting samples, and completing all the tests. So while we had that time limitation, we did fulfill our project's goal of pioneering data in the area just so we can build a foundation for the next 2 years of the program. So we also found limitations with the survey. Like I said, we decided not to go with the Quanah Bay Indian Community Survey because we felt it was rushed and it's just too sensitive a topic to touch on right now. So like I said, we're going to be doing the survey with MTU instead. So in conclusion, the project that we've done over the past 8 weeks, we have fulfilled our objective of pioneering data in the area. We plan on conducting more samples and tests in the future to gather more reputable data for our report. We plan on conducting a survey in the future, as well as culminating a comprehensive report of the findings that we collected from all of our sample data. We would like to acknowledge the MTU Forestry Department, as well as other MTU faculty and staff, such as Dr. Rao, Professor Hati, and Dr. Ganu from the RU TECHSCENE Research Program. We would also like to thank the KBIC and the Natural Resource Department and the National Science Foundation for funding our project. Thank you.